Welcome to the second demo in our three-part series. This time, our focus will be on highly available stateful Docker containers. I will show you how DxEnterprise can facilitate failover or proactively move stateful containerized RDBMS instances, or any container for that matter, across our different Linux distributions, all while maintaining data persistence. With that, let's go ahead and get started. As you can see, we're starting with the same built-out Linux cluster in which we just made the native SQL Server instance highly available. Our first step is going to be to add another disk to the cluster. So I'll go down to the Storage Manager. This disk has previously been presented, so it is available in our Storage Manager. I'm going to speed up the steps here since you've already seen them once before. So after we have that done, I'm going to go ahead and add another vhost to the cluster. Give it a host name and IP address, just like we did before. And then we want both of our Linux nodes to be failover targets, so we'll add them both right here and press OK. So now we just need to allocate some storage to, actually one thing I forgot to do was to adjust the ordering on those failover targets, so let me take care of that quick. Okay, there we go. Now we just need to allocate our disk to the vhost. So select it there, press submit, and that vhost is all set for some workload. So we're going to add a Docker container to our cluster for the first time. So when we open the Docker management pane here, you'll see that we need to name our instance. We have the choice of a few different types of containers. However, you also have the option to select any other unlisted arbitrary image by using the custom blank template. There, I'm going to select a SQL Server on Linux instance in a container. Give it a port number. Enter our SA credentials, and don't forget to check the accept EULA box after that. And then the bottom box allows you to add any additional parameters, but in this case I'm just going to leave it blank. So we are all set. After clicking OK, we need to wait a few seconds for the workload to be added, and then we have successfully added a Docker container to our cluster once the green indicator light shows up. So there it goes. Next, I can just show you the details of the Docker container. You can see them on the right here. And my next step is going to be to add a few more Docker containers. So since you've seen all these steps before, I'll go ahead and speed up the video for a little while. But we are going to be adding a containerized instance of MySQL. Take care of everything there. Next, we are going to add a containerized instance of MongoDB. And then lastly, I'm going to add a containerized instance of Postgres. So in this case, I'm adding all 4 Docker containers to a single vhost. This will allow me to move them all together, but you can add as many or as few instances or containers to any given vhost as you would like to. From there, I'm going to click over to the cluster view that I showed you in part 1, and instead of sticking around on the instance view, we actually also have a view for your Docker containers under management. So just like the instance view, the container view gives you a nice concise look at all the containers you have under management, the vhost each is associated with, and some other details such as the host the workload is active on, which is indicated by the green rectangle. Now I'm going to demonstrate a manual failover of our containerized instances. I'm dragging the Postgres workload from Ubuntu to Red Hat Enterprise Linux but because all 4 of our containers are associated to the same vhost, they will all fail over to the Red Hat node. So there you see the instance begin restarting on the Red Hat node. And there goes our green dot. So now all 4 containerized workloads are functioning normally on the Red Hat node. As you can see, Docker containers function much like native instances in the DxEnterprise framework. You can initiate manual failovers, implement performance policies, and DxEnterprise will always take proactive action to keep your workloads up and running at the level their SLAs necessitate, all with intelligent automation ensuring best execution venue for each. That concludes part 2 of our demo series. We demonstrated stateful Docker HA with data persistence through failover. You saw us fail over a wide array of Docker images across 2 different Linux distributions, clustering capability that isn't available anywhere else.